All right, today we're tackling one of those classic GCSE maths problems, you know the ones. They throw algebra, Pythagoras, and 3D shapes all into one question. Let's get right into it.
So, the big question is, how do you actually guarantee you get full marks on a question like this? It's a real beast, right? This is typical higher tier stuff, and it's not just about knowing the formulas, it's about how you piece it all together.
So what's the secret? Well, it's not really a secret. We're going to follow the official blueprint, the mark scheme. This thing is literally the rule book. It tells us exactly what an examiner is looking for to award each and every mark. It's our roadmap to full marks.
Okay, let's start with step 1, using Pythagoras.
And check this out, straight from the mark scheme itself. It says the first mark, a P1 process mark, is for, and I'm quoting here, starting the process, using Pythagoras to form an equation for the slant height L. So that's our first mission. Let's go get that mark.
All right, so we kick things off with the classic Pythagoras' theorem. You know it. L squared equals h squared plus r squared. But here's the key piece of information from the problem. The radius r is 3/4 of the height h.
So what do? We just plug that right into our equation. Instead of r squared, we now have 3h over 4 squared. And this is a huge deal, because now our whole equation is only in terms of one variable, h. That makes things so much simpler down the line.
Okay, let's do the maths. If we square 3h over 4, we get 9h squared over 16. Now we add that to h squared. To do that, let's think of h squared as 16h squared over 16, right? So 16 plus 9 gives us 25. So we have 25h squared over 16. Now just take the square root of that whole thing, and boom, we get our slant height L, which is 5h over 4. And just like that, our first process mark is officially in the bag. Nice.
All right, step 1, done and dusted. Now for step 2, finding the surface area.
So back to our trusty mark scheme, what's next? It says our second P1 mark comes from forming a correct expression for the curved surface area in terms of a single variable. We've already got everything in terms of h, so we're all set for this. You probably remember the formula for the curved surface area of a cone, right? It's pi times r times L. And the best part is we already have expressions for both r and L just in terms of h. So you know what's coming next? We just substitute them in.
So we take pi, we multiply it by our r, which is 3h over 4, and we multiply that by our L, which is 5h over 4. What does that give us? Well, it gives us 15 pi h squared over 16. Yeah, I know it looks a little complicated, but the key thing is, it's all in terms of h. And that's our second process mark. We're on a roll.
Okay, so we've got the curved surface area, we've banked the mark, but hold on a second. Is that the whole story? The question asks for the total surface area. And that means, yep, we've missed something.
Exactly. This is a classic trip-up. The total surface area isn't just the curvy part. It's also the flat circular base at the bottom. So we've got to find the area of that base, which is just pi r squared.
So let's do that. The area of the base is pi r squared. We already know r is 3h over 4, so we just plug that in and square it. That gives us 9 pi h squared over 16. Perfect. Now we have both parts, the curved bit and the base. All right, we've got the curved area, we've got the base area. Now it's time for step 3, building the big equation.
And you guessed it, this is where we earned our third and final process mark. The mark scheme is looking for us to form and simplify a correct equation to find height. Let's do it.
It's pretty simple, really. We just add our two pieces together, the curved area plus the base area. And remember, the question told us right at the start that the total surface area is 54 pi. So we just set our whole expression equal to that. This is it, the equation that's going to give us our answer.
Now, let's tidy this up a bit. Since both our bits have the same denominator, 16, we can just add the numerators. So, 15 pi h squared plus 9 pi h squared, that's 24 pi h squared. So our equation now looks much cleaner. 24 pi h squared over 16 equals 54 pi. And that simplification right there, that just earned us our third P1 mark. Excellent.
Okay, we're in the home stretch now, just a bit of algebra to finish up. First things first, we can divide both sides by pi. Let's get rid of that. Then we can rearrange things to get h squared by itself. So we'll multiply by 16, divide by 24, and when you do all that, you get something really nice and simple. H squared equals 36.
And here we are, the final answer. All that's left is to find h.
So if h squared is 36, what's h? Well, the square root of 36 is, of course, 6. The height of the cone is 6. That is our answer. And that's not just a process mark, that's the final accuracy mark, the A1. Full marks. We did it.
So let's just recap how we got those 4 marks. First, P1 mark, for using Pythagoras to find the slant height. Second, P1 mark, for getting the curved surface area in terms of h. Third, P1 mark, for putting it all together into the complete equation. And finally, the A1 mark, for solving it and getting the right answer, 6. You see? It's a journey, a series of clear steps.
So think about it. This was just one problem, but what other tricky exam questions can you decode using this exact same logical approach? Once you realize that these big, scary questions are just a series of smaller, manageable steps, the very steps the mark scheme is looking for, then suddenly nothing seems impossible.